Yokohama Harbor, November 19th, 1942. The captured American Liberty ship sits low in the water, its hull streaked with rust and saltwater stains from 3 months crossing the Pacific. Naval architect Yoshio Hirai circles the vessel slowly in the grey morning light, his measuring tape clicking against steel plates that feel wrong beneath his calloused hands. 10,500 tons deadweight capacity. 441 feet of welded American construction that somehow survived submarine attacks, typhoon conditions, and 3 months of continuous operation without specialized maintenance. To his trained eye, honed by 3 decades building merchant vessels for Mitsubishi Heavy Industries, the ship looks almost offensively crude. No elegant curves, no refined engineering solutions. Just raw industrial capacity, wrapped in quarter-inch steel plate, welded together with seams that would make his master craftsman weep with professional shame. The hull, plating shows visible irregularities. The internal bracing lacks the mathematical precision Japanese structural engineering demands. Even the paint application appears rushed, with runs and thin patches that expose bare metal to salt air corrosion. His Type A standard cargo ships, by comparison, represent everything Japanese shipbuilding stands for. 7,000 tons of precisely calculated engineering, riveted seams inspected to tolerances measured in fractions of millimeters, hulls designed through meticulous hydrodynamic analysis to slide through water with minimal resistance, interior spaces arranged according to principles refined through 40 years of merchant vessel evolution. Structural members positioned exactly where stress analysis indicates maximum efficiency. Every plate cut precisely. Every rivet driven by craftsmen who spent years learning their trade. Every system designed for decades of reliable service with proper maintenance. Since 1937, Japan has built 140 Type A vessels with methodical perfection, each one a testament to craftsmanship that takes 18 months to complete from initial contract to final delivery. 18 months of skilled labor. 18 months of precision manufacturing, 18 months of quality control that ensures every vessel meets standards that have made Japanese merchant ships respected throughout the maritime industry. Owners in Singapore, Shanghai, and Hong Kong specifically request Japanese-built cargo vessels because of their reputation for reliability and efficient operation. The captured Liberty ship had been built in 70 days, 70 days from keel laying to launch. The number sits in Hirai's consciousness like a mathematical impossibility, like someone claiming to have run a marathon in 30 minutes. Mitsubishi's fastest construction time for a comparable vessel stands at 523 days, achieved only by working triple shifts and prioritizing that, putting hull above all other projects. That emergency schedule had been considered a remarkable achievement, proof of Japanese industrial capability under pressure. American shipyards are apparently operating under different laws of physics, different principles of engineering, different assumptions about what constitutes acceptable quality in ocean-going merchant vessels. Standing on the deck, clipboard in hand, Hirai can see the evidence everywhere. Welds that would never pass Japanese inspection standards, showing visible porosity and inconsistent penetration. Steel plates sheared without proper finishing, leaving edges that could initiate stress cracks under repeated loading. Interior spaces arranged for loading efficiency rather than optimal weight distribution, violating principles of naval architecture he learned as an apprentice. Deck beams positioned at regular intervals rather than calculated stress points. Bulkheads installed for cargo compartmentalization rather than structural support. Paint applied in single coats rather than the multiple layer systems Japanese specifications require. Everything about this vessel violates the principles he learned as an apprentice in 1911, refined through 20 years of practice, codified into standards that govern every Japanese shipyard from Mitsubishi and Kawasaki down to the smallest private facilities. His education under master shipwright Takeshi Yamamoto had emphasized quality above all else. A ship built properly serves for 40 years. A ship built carelessly sinks in 40 months. Yamamoto's voice still echoes in his memory during inspections. Check every weld twice. Measure every plate 3 times. Accept nothing less than perfection, because the ocean accepts no excuses. Yet this crude American freighter had crossed 8,000 miles of ocean, survived 2 submarine attacks documented in its salvaged logbooks, endured typhoon conditions that damaged professionally built Japanese vessels, delivered 4,000 tons of military cargo to Allied forces in the Philippines, and remained completely functional throughout its service life. No major mechanical failures, no structural problems, no systems requiring specialized repair beyond routine maintenance. The vessel had been captured not because of engineering defects, but because American naval forces abandoned it during a strategic withdrawal, leaving the ship intact for Japanese forces to examine. Japanese merchant losses in the Pacific now exceed 600,000 tons annually. American submarines hunt Japanese cargo vessels with methodical efficiency, sending precision-built ships to the bottom faster than Japanese shipyards can replace them. Each Type A vessel represents 18 months of skilled labor, 1,800 tons of increasingly scarce steel, and the accumulated expertise of craftsmen who cannot be rapidly replaced. Submarine commanders don't care about construction quality. A torpedo, detonating against a perfectly riveted hull, produces the same result as one striking crude welded plates. Dead ships sinking into deep Pacific waters, regardless of how beautifully they were built. The mathematics are becoming undeniable and devastating. Japan started the war with 6.1 million tons of merchant shipping. Current inventory stands at 4.8 million tons after 10 months of combat. Losses exceeding 50,000 tons monthly. New construction delivering approximately 40,000 tons monthly. The gap between destruction and replacement grows wider each month. By Hirai's calculations, at current loss rates, Japan's merchant fleet will be reduced below 3 million tons by the end of 1943. Below 3 million tons, the logistics network supporting military operations throughout the Pacific collapses. Raw materials from occupied territories cannot reach home island factories. Military equipment cannot reach forward positions. Supplies cannot sustain civilian populations. The entire war effort becomes unsustainable regardless of tactical victories. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Japan tried to build its own version of the Liberty ship. They would construct exactly 3 hulls before steel shortages made further production impossible. The story of those 3 ships would reveal a truth about industrial warfare that Japanese planners had been desperately avoiding. Sometimes copying American technology isn't enough. You have to understand why Americans built things the way they did in the first place, and sometimes understanding comes too late to matter. The conference room at Imperial Japanese Navy headquarters smells of cigarette smoke and salt air drifting through open windows overlooking Tokyo Bay on a humid December morning in 1942. Vice Admiral Shigetaro Shimada, recently appointed Navy Minister after his predecessor's failure to prevent Midway disaster, spreads American intelligence photographs across the mahogany table where 20 senior procurement officers wait in uncomfortable silence. These are men who have spent careers mastering the complexities of naval logistics, understanding shipyard capacity limitations, calculating material requirements down to the kilogram. They are about to discover that every assumption underlying their understanding of industrial capacity is wrong. The images show something unprecedented in naval history. An American shipyard in Richmond, California, launching a completed cargo vessel every single day. Not theoretical production estimates, not projected capacity based on optimal conditions, not propaganda photographs staged for morale purposes. Actual ships sliding down ways every 24 hours, while workers immediately begin assembling the next hull in the same space. The photographs, taken by reconnaissance aircraft operating from Wake Island before its capture, document assembly methods that violate every principle of shipbuilding. These officers learned during decades of naval service. Shimada points to a specific image with a wooden pointer, his voice carefully controlled despite the implications of what he's presenting. Henry J. Kaiser's Richmond Yard No. 2. 4 shipways operating simultaneously. Average construction time 72 days from keel to launch. Current production rate 1.6 ships per way per month. The pointer moves to another photograph showing prefabricated hull sections stacked like enormous steel boxes waiting for assembly. Each section built in fabrication shops away from the shipways, then lifted by 250-ton capacity cranes and welded into position during final assembly. The entire methodology represents everything traditional shipbuilding is not. The photographs document an industrial system that Japanese naval architects have been insisting cannot possibly exist. Ships require time. Complex vessels cannot be rushed without compromising structural integrity. Precision manufacturing demands patience and skilled oversight at every stage. Quality construction depends on craftsmen who spend years perfecting their techniques under master shipwrights. These American facilities appear to be mass-producing 10,000-ton cargo vessels, using methods better suited to manufacturing automobiles than building ocean-going ships. Assembly line techniques applied to shipbuilding. Interchangeable components, standardized sections, semi-skilled workers performing repetitive specialized tasks rather than comprehensive craftsmanship. Captain Hiroshi Tanaka, Director of Naval Construction Planning, stands to examine the photographs more closely. His hands shake slightly as he traces the outline of a prefabricated bow section. The implications are becoming clear. This isn't just faster construction. This is a completely different industrial philosophy. American engineers haven't found ways to build traditional ships faster. They've redesigned what a ship means at a fundamental level, optimizing for production rather than perfection. The distinction matters enormously because Japanese shipyards cannot simply copy American speed. They would need to abandon every principle of Japanese shipbuilding accumulated over half a century. More photographs circulate through the room. Liberty ships in various stages of completion. Workers welding hull plates while standing on scaffolding that allows 6 men to work simultaneously on a single seam. Massive diesel-powered generators providing electrical power for hundreds of welding stations operating in parallel. Prefabricated deckhouses lowered into position as complete units rather than assembled board by board. Engine rooms installed as entire packages, wired and plumbed before being placed in the hull. Every image shows production techniques that prioritize speed over craftsmanship, volume over quality, adequate performance over optimal engineering. The intelligence data accompanying the photographs tells an even more disturbing story. American shipyards completed 195 Liberty ships in 1942. Production projections for 1943 estimate 650 to 700 vessels. By 1944, assuming current expansion plans proceed on schedule, American capacity could reach 900 Liberty ships annually, plus additional construction of faster Victory ship designs. The numbers represent industrial output on a scale Japanese planners had never seriously contemplated. Not because they lacked imagination, but because such production rates seemed physically impossible given material and labor constraints every industrial nation faces. Shimada allows the silence to extend while officers absorb the implications. Japan's entire merchant shipbuilding industry, including all private yards, naval arsenals, and improvised conversion facilities, delivered 68 cargo vessels of all types during 1942, hulls ranging from 2,000-ton coastal freighters to the sophisticated 7,000-ton Type A vessels that represent Japanese engineering at its finest. 68 ships requiring the total output of every major shipyard in the empire. America had built nearly 3 times that number of vessels, each substantially larger than Japanese equivalents. And American production was still accelerating, while Japanese capacity remained essentially static, limited by steel availability, skilled labor shortages, and facility constraints that could not be easily expanded. The comparison isn't just unfavorable, it's catastrophic. American shipyards are replacing merchant losses faster than German submarines can sink Allied vessels. Japanese shipyards cannot replace losses even close to the rate. American submarines are destroying Japanese merchant fleet. The maritime war of attrition is being won by industrial capacity, not torpedo effectiveness or tactical brilliance. And Japan is losing that industrial war so decisively that no amount of naval skill or sacrifice can compensate. Hirai studies the reconnaissance images with growing awareness of Japan's fundamental miscalculation about the nature of modern industrial warfare. His government had assumed American shipbuilding operated under the same constraints that limited Japanese production. Scarce materials requiring careful allocation, skilled workers who needed years of training under experienced masters, construction techniques emphasizing individual quality over production volume, manufacturing systems designed around craftsman expertise rather than process efficiency. Every assumption was wrong in ways that made direct comparison meaningless. The Americans had designed an entirely different system from the keel up, literally reimagining what shipbuilding could be when, freed from traditional assumptions about how vessels must be constructed, not better craftsmanship producing superior individual ships. Better production methodology creating adequate ships in overwhelming quantities. The distinction represented a fundamental philosophical difference about industrial purpose. Japanese shipbuilding asked, how perfect can we make each vessel within our resource constraints? American shipbuilding asked, how many adequate vessels can we produce with our available resources? Different questions leading to completely different solutions. The Liberty ship program had begun in 1940 when British orders for cargo vessels overwhelmed existing American shipyard capacity. Royal Navy losses in the Atlantic had created desperate demand for replacement tonnage, but traditional American shipyards were already fully committed to naval construction programs. The British Merchant Shipping Mission had approached the United States Maritime Commission with requirements that seemed impossible to fulfill using conventional shipbuilding methods. 200 ships needed immediately. More vessels required continuously thereafter for duration of the war. Construction rates that would demand capabilities American shipyards simply did not possess using traditional techniques. Admiral Emery Scott Land, chairman of the Maritime Commission, had turned to an unlikely group of industrial contractors with no shipbuilding experience whatsoever. Henry Kaiser and Stephen Bechtel led a consortium called the Six Companies, famous for constructing Hoover Dam, Bonneville Dam, and Grand Coulee Dam ahead of schedule. They knew nothing about ships. They knew everything about managing large-scale construction projects, using innovative techniques, abundant resources, and aggressive scheduling. Land asked them a simple question. Can you build ships the way you build dams? Can you treat vessels as assembled structures rather than crafted objects? Can you manufacture cargo capacity instead of building individual ships? Kaiser's answer transformed American maritime industry overnight. His team redesigned the entire shipbuilding process as an assembly operation rather than a construction project. They borrowed mass production techniques from automobile manufacturing, standardized components manufactured in thousands of factories across America, prefabricated sections built in climate-controlled shops rather than on exposed shipways, specialized workstations where semi-skilled laborers performed repetitive tasks they could learn in weeks. Quality control based on tolerances, adequate for function rather than optimal for performance. The entire system optimized for maximum output using available resources rather than maximum quality using scarce expertise. Traditional shipyards had regarded Kaiser's approach with professional contempt initially. You cannot build quality ships using assembly line methods. Ocean-going vessels require craftsmanship, not mass production. Welding will never match riveting for structural integrity. Semi-skilled workers cannot produce reliable vessels. Every criticism proved correct in the sense that Liberty ships were indeed inferior to traditionally built vessels in measurable ways. Heavier hulls, cruder construction, more frequent maintenance requirements, shorter expected service life. But the criticism missed the strategic point entirely. Kaiser wasn't trying to build better individual ships. He was trying to build more total shipping capacity than could be destroyed. And for that purpose, adequate quality delivered quickly mattered more than superior quality delivered slowly. The results had vindicated Kaiser's philosophy with mathematical brutality. His Richmond shipyards, built on empty land in 1940 and 41, were producing ships faster than established shipyards with 50 years of experience. Oregon Shipbuilding Corporation launched the Star of Oregon, the Northwest's first Liberty ship, in September 1941 after 131 days of construction. Impressive for a completely new facility. By November 1942, the same yard was completing Liberty ships in 10 days from keel laying to launch. Not as publicity stunts, but as routine production runs optimized through continuous process improvement. Peary, built in Kaiser's Richmond No. 2 yard, had been assembled in 4 days, 15 hours, and 29 minutes, including final fitting out. 4 days to build a 10,000-ton ocean-going vessel. The achievement seemed to mock everything Hirai understood about shipbuilding physics. The key to American speed lay not in rushing traditional construction, but in completely rethinking what ship construction meant. Liberty ships weren't built sequentially from keel to superstructure like traditional vessels. They were assembled from enormous prefabricated modules constructed simultaneously, in fabrication shops surrounding the shipways. While one hull underwent final assembly on the slipway, components for 6 subsequent ships were being manufactured in parallel. Bow sections, stern assemblies, deck houses, engine rooms, each piece built as a complete unit with all internal systems installed, then lifted by massive cranes and welded into position during final assembly that took days rather than months. A worker might spend weeks installing electrical conduit and lighting fixtures in a section that would eventually become part of the forward hold, never seeing the actual ship until the day his prefabricated module was hoisted aboard. That worker didn't need to understand overall ship design or comprehend how his section related to the vessel's total structure. He needed to know how to install conduit according to standardized plans that specified exact positions for every junction box, every wire run, every fixture mounting. The skill requirements dropped from years of training to weeks of specialized instruction. Quality came from precise, standardized procedures rather than craftsman expertise. The technique eliminated construction bottlenecks that plagued traditional shipbuilding. In Japanese yards, craftsmen worked sequentially. Hull plating completed before internal framing. Internal framing finished before deck installation. Decks laid before superstructure building. Superstructure completed before machinery installation. Each stage dependent on previous work, creating inevitable delays when any step encountered problems. A mistake in hull plating rippled through the entire construction schedule. American parallel production isolated problems to individual sections. A delay fabricating one deckhouse didn't affect hull assembly or engine room construction, proceeding simultaneously in other shops. Shimada's procurement data reveals the scale of American advantage with mathematical precision that makes denial impossible. American shipyards completed 195 Liberty ships in 1942. Japan's entire merchant shipbuilding industry, including all private yards and naval arsenals, delivered 68 cargo vessels of all types during the same period. American vessels averaged 10,500 tons deadweight capacity. Japanese vessels averaged 4,300 tons. Total American production, 2,047,500 tons of cargo capacity. Total Japanese production, 292,400 tons. America built 7 times more shipping capacity in a year when Japanese industry was supposedly operating at maximum wartime production rates. By 1943, American production would reach nearly 700 ships annually, not 700 small coastal freighters. 700 ocean-going cargo vessels, each capable of hauling enough war material to equip an entire infantry division. The projected production for 1943 represented more shipping capacity than existed in Japan's entire pre-war merchant fleet. America would build Japan's entire peacetime maritime industry in 12 months, while simultaneously replacing Atlantic convoy losses and supporting Pacific operations that required unprecedented logistics capacity. Japan's equivalent standardization program had produced the Type A cargo ship, 7,000 tons deadweight capacity, diesel engines providing reliable propulsion at modest speeds, hulls designed for efficient ocean transit and reasonable cargo capacity. 140 vessels completed between 1937 and 1942 at an average cost of 4.2 million yen per unit. Construction time averaging 18 months from contract to delivery. The ships represented everything Japanese industry did well: careful planning, precision manufacturing, attention to detail that produced vessels capable of decades of reliable service. American Liberty. Ships carried 10,500 tons of cargo using steam engines that cost half as much as diesel power plants but required more fuel and crew. Their hulls were heavier, their construction cruder, their expected service life shorter. Yet American yards were delivering these adequate vessels at a rate that made Japanese precision irrelevant through simple arithmetic of overwhelming production volume. Shimada's procurement data reveals the scale of the challenge with mathematical brutality. American shipyards completed 195 Liberty ships in 1942. Japan's entire merchant shipbuilding industry, including all private yards and naval arsenals, delivered 68 cargo vessels of all types during the same period. By 1943, American production would reach nearly 700 ships annually. Japanese capacity remained locked at approximately 70 vessels per year, despite desperate efforts to expand production. The steel allocation reports tell an even grimmer story. Building a single Type A cargo ship requires 1,800 tons of steel plate. Japan's total monthly steel production, available for merchant shipbuilding, stands at 14,000 tons. Maximum theoretical output, 7.7 ships monthly, or 92 vessels annually. This assumes no steel allocation for naval construction, no resources for repair facilities, no material for essential infrastructure. The actual number Japanese yards can deliver while maintaining naval programs hovers around 6 merchant vessels per month. American steel production allocated to Liberty ship construction alone exceeds 100,000 tons monthly. Henry Kaiser's Richmond shipyards receive enough raw material every week to build what Japan produces in a month. The disparity isn't incremental, it's categorical. Japan is trying to fight an industrial war with an industrial base designed for peacetime commerce. Hirai receives his orders on December 7, 1942. Examine the captured Liberty ship thoroughly. Determine if Japanese shipyards can build equivalent vessels. Provide detailed cost and timeline estimates for mass production. The assignment carries the weight of national desperation. Merchant losses now exceed 1 million tons annually. Submarines sink Japanese cargo vessels faster than traditional construction methods can replace them. Without a dramatic increase in shipbuilding capacity, Japan's logistics network will collapse within 18 months, regardless of military victories at sea or on land. His inspection team spends 3 weeks measuring, photographing, and documenting every aspect of the Liberty ship's construction. The hull plates average 6/16 of an inch thickness. Japanese Type A vessels use half-inch plate for comparable sections, prioritizing strength over weight efficiency. The American welding appears rushed by Japanese standards, with visible irregularities that would never pass Mitsubishi's quality control. Yet, structural testing reveals adequate strength for the vessel's intended service life. The propulsion system relies on a reciprocating steam engine, producing 2,500 horsepower at 76 revolutions per minute. Japanese diesel engines generate similar power with better fuel efficiency, but require precision machining of components that demand specialized manufacturing facilities. The American power plant can be mass-produced by any competent heavy equipment factory with minimal specialized tooling. Most striking is the modular construction methodology. The Liberty ship wasn't built sequentially from keel to superstructure like traditional vessels. American yards constructed enormous sections in fabrication shops far from the shipways. Hull sections, deck houses, engine rooms. Each piece built separately, then lifted by massive cranes and welded into place during final assembly. A worker might spend months installing electrical conduit in a section that would eventually become part of the forward hold, never seeing the actual ship until the day his prefabricated module was hoisted aboard. The technique eliminated construction bottlenecks and allowed parallel manufacturing of components. While workers assembled one hull on the slipway, dozens of sections for subsequent ships were being fabricated in surrounding workshops. The entire system was designed for continuous production flow rather than sequential craftsmanship. Hirai's report to naval procurement runs to 87 pages of detailed technical analysis. The conclusion requires only 3 paragraphs. Japanese shipyards can build vessels equivalent to American Liberty ships. The required modifications to existing facilities will take 8 to 12 months. Material requirements will consume 70% of available steel allocation. Labor demands will require retraining 6,000 skilled shipbuilders to perform specialized assembly tasks rather than traditional craftsman roles. Projected construction time per vessel, 95 days from keel laying to launch. Maximum production capacity, assuming unlimited material and labor. 3.2 vessels monthly from all Japanese shipyards combined. The mathematics reveal Japan's industrial inadequacy with brutal precision. American production in 1943 will reach 50 merchant ships per day across all U.S. shipyards. Japan's maximum theoretical capacity, 3 ships per month. The United States will build more cargo vessels in 3 days than Japan can produce in 30. No amount of superior craftsmanship can overcome that disparity. No degree of individual quality matters when the opponent manufactures adequate vessels in quantities that exceed your entire industrial capacity. Spring arrives at Mitsubishi's Nagasaki shipyard with orders that reflect Japan's deteriorating strategic position. Construct 3 modified Type A vessels incorporating simplified Liberty ship production techniques. Priority allocation of all available steel plate. Completion target, 6 months maximum. The project represents Japan's last attempt to increase merchant production before submarine losses make the entire merchant marine unsustainable. Hirai assembles his most experienced engineers and explains what they're being asked to abandon. No more hand-fitted components, no more individual craftsmanship, no more tolerances measured in fractions of millimeters. They will build ships the American way, accepting adequate quality in exchange for faster construction and reduced material consumption. The resistance is immediate and visceral. Master craftsmen who spent decades perfecting their skills understand they're being asked to produce inferior work. Welders, accustomed to inspection standards that reject anything less than perfection, must now accept seams that merely meet minimum structural requirements. The entire philosophy contradicts everything Japanese shipbuilding represents. Hirai understands their objections because he shares them, but merchant losses now exceed 4 ships per week. Traditional methods cannot possibly replace vessels at the rate submarines are sinking them. Building better ships means nothing if you cannot build enough ships to matter. The first modified hull takes shape through April and May of 1943, like a compromise between 2 incompatible philosophies. American welding techniques speed construction, but feel wrong to craftsmen trained in precision riveting. Simplified internal bracing reduces weight, but violates structural principles. Hirai learned 30 years ago. Standardized components eliminate custom fitting, but create gaps and misalignments that traditional methods would never accept. Every shortcut saves time and material, while producing a vessel that feels fundamentally wrong to everyone involved in its construction. Material allocation arrives in carefully rationed monthly shipments, 1,400 tons of steel plate for the first hull, not the 1,800 tons Japanese specifications require, not even close to the 2,100 tons the original Liberty ship design uses. just enough to build something adequate if every plate is utilized with absolute efficiency. The mathematics force constant compromise. Hull sections designed for 6/16" plate are built with quarter-inch steel, compensated through additional structural bracing. Deck plates specified at half-inch thickness become 3/8 inch with reinforced supports. The ship grows lighter and potentially weaker with each material-saving modification. By July, the first hull sits in dry dock while workers install the propulsion system. The engine represents another compromise between Japanese precision and American practicality. Mitsubishi diesel engines require components machined to tolerances that demand specialized facilities and skilled labor Japan can no longer spare. The alternative is a reciprocating steam power plant manufactured using simplified techniques that can be mass-produced by heavy equipment factories. The resulting engine weighs more, consumes more fuel, requires larger crews, and produces comparable power while remaining dramatically easier to manufacture. American practicality, defeating Japanese refinement through simple economics of production efficiency. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The hull launch ceremony on September 18, 1943, draws government officials and naval procurement officers who need to witness success. The vessel slides down the ways into Nagasaki Harbor, carrying everything Japan has learned about compromising quality for quantity. 93 days from keel laying to launch, faster than any Japanese merchant vessel in history. Still 6 weeks longer than average American Liberty ship construction time and consuming materials enough to build only 3 such vessels before exhausting Japan's monthly steel allocation for merchant construction. Test trials reveal performance that meets minimum specifications without exceeding them. Maximum speed of 10.8 knots. Cargo capacity of 7,800 tons deadweight. Range of 8,000 nautical miles with loaded fuel tanks. The numbers fall short of both American Liberty specifications and Japanese Type A performance, representing the worst of both approaches. Not crude enough to be mass-produced, not refined enough to justify the construction time and materials invested. The second and third hulls proceed through autumn with growing awareness that the project has failed before completion. Steel allocation for September arrives at 1,100 tons instead of the requested 1,400. October brings 960 tons. November delivers 820 tons as steel mills prioritize naval construction over merchant vessels. By December, procurement officers inform Mitsubishi that no further material will be available for merchant construction in the foreseeable future. Every available ton must go to naval vessel production and repair facilities, overwhelmed by combat damage from battles across the Pacific. Destroyer losses at Guadalcanal require replacement. Cruiser damage from Tassafaronga demands immediate repair. Carrier construction programs cannot be delayed. Merchant shipping, despite its essential role in sustaining the entire war effort, ranks below direct combat vessels in allocation priorities. The 3 modified cargo ships represent Japan's entire civilian shipbuilding program for 1943. 3 hulls carrying everything Japanese engineers learned about simplified construction. 3 vessels demonstrating that Japan could indeed build ships faster by accepting American production techniques. 3 units proving that adopting enemy methodology changes nothing when you lack the industrial capacity to implement that methodology at scale. The knowledge gained comes too late and matters too little. Understanding how Americans build ships quickly does not provide the steel to build Japanese ships in comparable quantities. 3 ships delivered over 6 months, while American yards launched more than 700 Liberty vessels during the same period. 6 months of Japan's maximum effort at simplified merchant construction had produced what American shipyards delivered every 11 hours. 3 hulls consuming Japan's entire merchant steel allocation, while the United States built merchant ships faster than submarines could sink them. The arithmetic of industrial capacity had rendered Japanese craftsmanship strategically meaningless. Individual ship quality became irrelevant when the opponent produced adequate vessels in overwhelming quantities. The captured Liberty ship still sits at Yokohama through early 1944, a reminder of what industrial warfare actually requires. Not superior individual products built by master craftsmen. Superior production systems capable of overwhelming quality with quantity. Systems that American engineers had designed deliberately to maximize output using available resources, rather than optimize performance through scarce expertise. Every crude weld on that American hull represents a conscious decision to accept adequacy rather than pursue perfection. Every heavy steel plate reflects choice to use abundant materials rather than optimize for weight efficiency. The entire vessel embodies industrial philosophy fundamentally different from Japanese tradition. Hirai visits the captured ship one final time in February 1944, before it's pressed into Japanese service carrying supplies to southern Pacific bases. Standing on the deck where his journey began 15 months earlier, he understands the lesson this crude American freighter was teaching all along. The ship wasn't trying to be beautiful, wasn't aspiring to perfection, wasn't demonstrating what could be built given unlimited time and resources. It was showing what could be manufactured given limited time and adequate resources. Showing that good enough delivered today beats perfect delivered never. Showing that industrial warfare rewards production systems over products, quantity over quality, practical adequacy over theoretical optimization. The methodology extends beyond shipbuilding to every aspect of industrial warfare that Japan has been losing since the conflict began. American aircraft aren't necessarily superior to Japanese fighters, but American factories produce enough adequate fighters to overwhelm superior Japanese aircraft through sheer numerical advantage. American tanks aren't individually better than Japanese armor, but American plants manufacture enough acceptable tanks to achieve tactical dominance through quantity. American artillery isn't more accurate than Japanese guns, but American foundries cast enough functional artillery to achieve fire superiority through volume. In every category, adequate quantity defeats superior quality when the quantity disparity becomes sufficiently large. Japan's industrial tradition emphasized building the best possible product within resource constraints. Each aircraft optimized for maximum performance. Each tank designed for optimal armor firepower mobility balance. Each artillery piece manufactured to deliver maximum accuracy. The approach produced world-class weapons when resources allowed time for proper development and construction. But modern industrial warfare doesn't reward world-class weapons unless you can produce world-class weapons in world-class quantities. Perfection matters only when you can manufacture perfection faster than the enemy manufactures adequacy. America had recognized this truth earlier and deeper than any other industrial power. Henry Ford's assembly lines demonstrated the principle decades before World War II. Mass production of acceptable quality products at low cost beats artisan production of superior quality goods at high cost in free market competition. The winner isn't who makes the best automobile. The winner is who makes acceptable automobiles in quantities customers can afford. Industrial warfare simply applied this market principle to military production. The winner isn't who builds the best weapons. The winner is who builds acceptable weapons in quantities that overwhelm the enemy. Liberty ships represented this philosophy perfected through wartime urgency. Not the best cargo vessels, not the most efficient designs, not the longest-lasting ships, just good enough freighters built fast enough in numbers, large enough to replace losses faster than submarines could create them. The ugly ships that sophisticated naval architects mocked in 1941 were winning the logistics war by 1943 through simple arithmetic of continuous production, overwhelming continuous destruction. Hirai watches the Liberty ship depart Yokohama Harbor for what will be its final voyage under Japanese flag. American submarine Balao will sink it 3 weeks later off Truk with 2 torpedoes that send the crude but functional vessel to the bottom in 11 minutes. The cruise dies, the cargo is lost. But the loss means nothing to American logistics because Kaiser's yards will launch 2 replacement Liberty ships the day this one sinks. and 2 more the next day, and 2 more the day after that. Continuous production, defeating continuous destruction through industrial capacity that Japan cannot match, cannot duplicate, cannot overcome, regardless of superior craftsmanship or engineering excellence. The steel shortage analysis Hirai receives in January 1944 documents the mathematics of Japan's defeat with bureaucratic precision. Total Japanese steel production, including home islands, Korea, and Manchuria, peaks at 7.8 million tons annually. American steel production in 1943 reached 89 million tons. The United States produced more steel in 40 days than Japan manufactured in 12 months. 11.4 times more steel. Not 11.4% more, not 11.4 times faster, 11.4 times total volume. This disparity propagates through every aspect of industrial warfare. More ships, more tanks, more aircraft, more artillery, more everything that modern combat requires. More faster, more cheaper, more continuously throughout the conflict, while Japan's production rates stagnate or decline due to resource exhaustion and facility damage. Even if Japanese shipyards had successfully copied American Liberty ship construction techniques perfectly, material shortages made mass production impossible, regardless of manufacturing efficiency. The steel needed to build 10 modified cargo vessels could construct 2 destroyers desperately needed for convoy protection against submarines sinking merchants faster than replacement construction. Resources allocated to merchant shipping came directly from naval construction programs, already unable to replace combat losses, accumulating through battles at Guadalcanal, Santa Cruz, Tassafaronga, and dozens of other engagements throughout the Pacific. Every choice forced impossible compromises between inadequate alternatives. The submarine warfare data reveals the futility of trying to solve industrial problems through engineering excellence alone. Japanese merchant losses in 1943 totaled 3.8 million tons of shipping. New construction delivered 260,000 tons. The gap between destruction and replacement had become mathematically insurmountable. Even if every Japanese shipyard worked at maximum, theoretical capacity building only merchant vessels with no naval construction whatsoever, production would still fall 1 million tons short of replacing submarine losses. And working at maximum capacity would require steel allocations that would shut down destroyer, cruiser, carrier, and battleship construction entirely. The war demands both merchant shipping and naval vessels simultaneously, but industrial capacity cannot provide adequate quantities of either. American shipyards weren't just building Liberty ships faster than Japanese yards could build comparable vessels. They were building Liberty ships in quantities that made replacement cost irrelevant to strategic planning. Submarines might sink 500,000 tons of Allied shipping monthly, but American yards launched 800,000 tons of new vessels during the same period. The Allied merchant fleet grew larger throughout 1943, despite submarine warfare that sank more tonnage than Japanese industry could produce in a year. Industrial capacity had become the decisive weapon, rendering individual ship quality meaningless in the face of overwhelming production volume. The war's reality had exposed Japan's fundamental strategic miscalculation about the nature of modern industrialized conflict. Military planners had assumed industrial warfare meant building better weapons with superior technology. American industry had demonstrated that modern war actually required building adequate weapons in overwhelming quantities using whatever resources were available. Liberty ships weren't better than Japanese cargo vessels by any traditional measure of ship quality. They were good enough, built fast enough, in numbers large enough to make quality comparisons strategically irrelevant. A crude but functional ship delivered today mattered more than a perfect vessel completed 18 months from now, and 1,000 crude but functional ships mattered infinitely more than 100 perfect vessels, regardless of how much better those perfect ships might be individually. Mitsubishi's shipyard transitions fully to naval construction by March 1944. The brief experiment with simplified merchant building ends not through design failure, but through resource exhaustion that makes any merchant construction impossible. The three modified cargo ships that had consumed 6 months of intensive effort, representing Japan's maximum capability for simplified construction, would spend the remainder of the war shuttling supplies between Japan and occupied territories, constantly targeted by submarines that eventually sent 2 of the 3 to the bottom before the surrender. The survivors lasted just 19 months in service. American Liberty ships, built in 70 days, would sail for decades after the war's conclusion, many serving into the 1960s as commercial freighters, demonstrating that adequate construction properly maintained outlasts sophisticated construction inadequately supported. Hirai stands on Mitsubishi's dock, watching the third modified hull prepare for sea trials on a grey December afternoon. The vessel represents everything his team accomplished through 6 months of concentrated effort: simplified construction, reducing build time by 63% compared to traditional methods; material efficiency lowering steel consumption by 22%; quality standards adjusted to accept adequacy rather than perfection. Every compromise made in the name of increased production capacity. None of it matters. 3 ships. Total deadweight capacity of 23,400 tons. American yards had delivered that much cargo capacity every 16 hours throughout 1943. Japan's maximum effort at simplified construction had produced in 6 months what Henry Kaiser's Richmond facility launched before noon on any given day. The numbers tell a story of categorical industrial inadequacy that no amount of engineering skill can overcome. The steel shortage analysis Hirai receives in January of 1944 documents the mathematics of Japan's defeat with bureaucratic precision. Total Japanese steel production, including home islands, Korea, and Manchuria, peaks at 7.8 million tons annually. American steel production in 1943 reached 89 million tons. The United States produced more steel in 40 days than Japan manufactured in 12 months. This disparity propagated through every aspect of industrial warfare: more ships, more tanks, more aircraft, more artillery, more everything that modern combat requires. Even if Japanese shipyards had successfully copied American Liberty ship construction techniques, material shortages made mass production impossible, regardless of manufacturing efficiency. The steel needed to build 10 modified cargo vessels could construct 2 destroyers desperately needed for convoy protection. Resources allocated to merchant shipping came directly from naval construction programs already unable to replace combat losses. Every choice forced impossible compromises between inadequate alternatives. The submarine warfare data reveals the futility of trying to solve industrial problems through engineering excellence. Japanese merchant losses in 1943 totaled 3.8 million tons of shipping. New construction delivered 260,000 tons. The gap between destruction and replacement had become mathematically insurmountable. Even if every Japanese shipyard worked at maximum theoretical capacity building only merchant vessels, production would still fall 1 million tons short of replacing submarine losses. American shipyards weren't just building Liberty ships faster, they were building them in quantities that made replacement cost irrelevant. Submarines might sink 500,000 tons of Allied shipping monthly, but American yards launched 800,000 tons of new vessels during the same period. The Allied merchant fleet grew larger throughout 1943 despite submarine warfare that sank more tonnage than Japanese industry could produce in a year. Industrial capacity had become the decisive weapon, rendering individual ship quality meaningless in the face of overwhelming production volume. The war's reality had exposed Japan's fundamental strategic miscalculation. Military planners had assumed industrial warfare meant building better weapons with superior technology. American industry had demonstrated that modern war actually required building adequate weapons in overwhelming quantities using whatever resources were available. Liberty ships weren't better than Japanese cargo vessels. They were good enough, built fast enough, in numbers large enough to make quality comparisons irrelevant. A crude but functional ship delivered today mattered more than a perfect vessel completed 18 months from now. Mitsubishi's shipyard transitions fully to naval construction by March of 1944. The brief experiment with simplified merchant building ends not through design failure, but through resource exhaustion. The 3 modified cargo ships that had consumed 6 months of intensive effort would spend the remainder of the war shuttling supplies between Japan and occupied territories. Constantly targeted by submarines that eventually sent 2 of the 3 to the bottom, the survivors lasted just 19 months in service. American Liberty ships, built in 70 days, would sail for decades after the war's conclusion. The captured American freighter remains anchored at Yokohama through early 1944, its crude construction now telling a different story than Japanese engineers had understood in 1942. Those rough welds and heavy steel plates weren't signs of inferior craftsmanship. They were features of a production system designed for mass manufacturing using available resources and semi-skilled labor. American engineers hadn't built the best possible ship. They had built the ship that could be manufactured by the thousands using America's actual industrial capacity rather than theoretical optimal capabilities. Every element of Liberty ship design reflected this philosophy. Reciprocating steam engines instead of diesels, because reciprocating plants could be mass-produced by any heavy equipment manufacturer. Welded construction instead of riveting, because welding allowed prefabrication of large hull sections. Standardized components throughout, because standardization enabled parallel production of parts in factories far from shipyards. The entire system was optimized not for individual ship performance but for industrial production efficiency. Japanese shipbuilding had taken the opposite approach. Each vessel optimized for performance within material constraints. Every component precision manufactured to maximize quality within available resources. Ships designed as individual units to be completed sequentially by skilled craftsmen. The methodology produced superior individual vessels, while making mass production impossible regardless of available resources. Master craftsmen cannot be trained in weeks. Custom components cannot be prefabricated by general factories. Sequential construction cannot be parallelized. The lesson emerges with brutal clarity through 1944 as merchant losses accelerate beyond any possibility of replacement. Superior individual craftsmanship becomes strategically worthless when the opponent manufactures adequate products in quantities that overwhelm quality advantages. Japan had built some of the finest cargo vessels in maritime history. America had built a cargo vessel production system that could manufacture adequate ships faster than they could be destroyed. In industrial warfare, the side that builds more wins, not the side that builds better. By autumn of 1944, Japan's merchant fleet has been reduced to 43% of its December 1941 tonnage. Submarines hunt cargo vessels with impunity, while naval escorts desperately needed for convoy protection are pulled away to replace fleet losses from carrier battles. The supply lines that once connected the home islands to occupied territories throughout Asia and the Pacific constrict like arteries blocked by strategic paralysis. Without merchant shipping, Japan's industrial base cannot access raw materials from conquered territories. Without raw materials, factories cannot produce military equipment. Without military production, the war effort collapses regardless of troop skill or command brilliance. The mathematics had been inevitable from the moment Japan chose to fight an industrial war with an industrial base 1/10 the size of its opponent. Not 1/10 less efficient. 1/10 the actual size in terms of steel production, manufacturing capacity, electrical power generation, machine tool availability, and trained workforce. No amount of superior craftsmanship could overcome that fundamental disparity. No degree of individual excellence mattered when America could produce 10 adequate items for every perfect Japanese product. The 3 modified cargo ships Japan had built, trying to copy Liberty ship methodology, served as mathematical proof of industrial inadequacy. 3 vessels representing 6 months of maximum national effort. American yards had launched 677 Liberty ships during that same period. The United States built more merchant shipping in a single day than Japan produced in 2 months of concentrated work using its entire available steel allocation and best remaining workforce. The comparison wasn't just unfavorable, it was catastrophic. Hirai stands alone on Nagasaki dock on a cold January morning in 1945, watching submarine I-367 tie up at the pier where the first modified hull had launched 15 months earlier. The submarine carries steel plate salvaged from damaged merchant vessels, metal so precious that Naval Command now orders systematic recovery of scrap from sunken ships when submarine crews can reach wrecks in shallow water. Japan has been reduced to recycling yesterday's construction to build tomorrow's inadequate replacements. The industrial circle closes into spiral of decline that no amount of engineering innovation can reverse. The lesson Liberty ships taught wasn't about shipbuilding. It was about production systems and industrial philosophy. American success came not from superior technology, but from superior methodology optimized for mass production using available resources. Liberty ships used older engine technology, cruder construction techniques, and heavier materials than comparable Japanese vessels. They represented deliberate acceptance of adequate quality in exchange for production volume that made quality comparisons strategically meaningless. Japan had spent decades perfecting the art of building individual ships. America had perfected the science of building ship production systems. In industrial warfare, production systems mattered more than products. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.